Hello everyone, welcome back. We're still on programming with C++. Today we'll be dealing with the expressions and statements, right? So today we'll be diving into iterative statements. Our objective at the end is to know what iterative statements are and what they do, to learn the various types of iterative statements, to practice on using iterative statements, right? So when we say iterative statements, they are known as loops. They are used to execute parts of code repeatedly based on condition or a set of conditions. And we know loops occur repeatedly. So iterative statements are the best to use when you want to execute a part of code repeatedly based on a certain or given criteria or conditions. Iterative statements also are used for performing repetitive tasks efficiently, as I said. Right, there are mainly three types of iteration statements. We have the for loop, the while loop, and the do while loop in programming. So this is the structure or the syntax of it. We say while this condition, while the variable follows this condition, the compiler should display this for me. So you say while, then your condition, then your statement. Alright, so while it follows a condition, display this for us, right? For the do while loop, we say compiler should do or display the statement while the variable follows the expression. So this one is it's output the statement before the expressions are coming. Now for the for loop, we say the initial statement condition, then the expression, then your statement. Or we can also say the for declaration, the expression, and the statement. I'll actually be treating the theoretical session now. Then when I'm done, I'll dive into the practical session. So if you have any challenges with what I've just said, just hold on and relax. I'll dive into the practical session and give more tutorials on that. So for the for statements, we say they are used to iterate over a range of values or elements in a collection. So they are used to iterate, like say a set of values or range of values in a collection. Right, so this is the syntax. We say the for keyword should be but, then your initial statement, then your loop condition, then your update statement. And now this is where we can use the decrement and the increment operator. Then when you're done giving your condition, you instruct the compiler to display a statement if your variable follows the condition or criteria you've given. So this is, we say a for statement is also useful for expressing a loop without an explicit termination condition. So here we omit all the three statements as the initial statement, the loop condition, and the update statement. We omit all these conditions and we say it should just output anything without explicit termination. So this one, you're instructing the compiler to just run. It's just overflows. It displays a forever something. So let's say if you instruct it to display a statement, right, and you bring it in this function this way, it will display that function without termination because you didn't give it any condition it should follow, right? So this is a basic C++ program of how to do the system overflow, right? Displaying and let's say a statement without any explicit termination. Right, so for the for loop, this is also a basic diagram for explaining the for loop. So we say the initial statement, then the loop condition. So if the loop condition is true, then the compiler should display the statement, right? And it should, if the loop condition is true, then you give your statement, then you update the statement, right? Then you go back, you do the same process. But if it's false, you display the statement. So we say For the for loop execution, the for loop executes as follows. So the initial statement executes first, right? Then the loop condition is evaluated. If the loop condition evaluates to true, then you execute the for loop statement. And when you're done with the for loop statement, you execute the update statement. That's the third expression in the parenthesis, right? So you repeat step 2 until the loop condition evaluates to false, right? So initial statement usually initializes a variable called the for loop control or for indexed or variable. So the initial statement is it initializes a variable the way we initialize a variable, that's assigning a value to a variable. So that's basically what the initial statement. So it's also known as the for loop control, or let's say for indexed or the variable. Yeah, so this is basically what we say the syntax. So we bring the keyword for. Now you see we initialize the variable. Say I. Mostly they use I not because that's the command. You can use any variable of your choice, but I just simply means the index of the for loop. So for, then you initialize the variable, then you give it a condition. Then when you're done, then you update your statement. So this is the increment operator. So this you're telling the compiler that we've initialized the variable this, right? And this is a condition. So if the variable follows this condition, then output the variable, then add 1 to the value of that variable being displayed. That's simply what the increment operator does. So it adds 1 after you've displayed the variable. It adds 1 to it. So then you display your. So this is the for, then the initial statement, your loop condition, the update statements, then finally your statements, the statements you want the compiler to display for you. For the while loop, the while loop executes as long as specifies conditions evaluates to true, right? So it's for the for loop, it executes as long as the specified condition evaluates to false, but for the while loop, as long as the condition evaluates to true. And while statements executes a while statement executes its control statement until its condition also becomes what? False. So it executes its control statement until the condition becomes false. So the syntax is you bring the while keyword, then your expression or your condition, then you give a statement for the compiler to display. So we say the statements can be simple or compound, whatever it is. The expression acts as a decision maker and it's usually a logical expression. So for the while loop, it's the expression is usually a logical expression and it acts as a decision maker. Right. So we also have the infinite loop. It continues to execute endlessly. That's how we have the for loop. It loops without any explicit termination. So that's the infinite loop. It continues to execute endlessly. So this can be avoided by including statements in the loop body that assure exit condition will eventually be false. So if you want to avoid the infinite loop, you include statements in the loop body that assure that the exit condition will eventually be false. So while statements is also useful for expressing a loop without an explicit termination condition, as I said earlier. So the while, then if it's true, then you display the statements, right? So this is also a simple diagram of how to execute the while loop. So this is the structure, the C++ structure of a while loop. So we initialize, unlike the for loop that the initialization statement is done inside of the parentheses. For the while loop, we initialize the variable first, then we say while, then you give the condition or the expression. So it's a decision maker, right? So while it is this, then you display this. The one you're done displaying the variable, then you increment it, or you can choose to decrement however you want it to do. For the do while loop, or statement, it is similar to the while statement, except that the condition comes after the body. So we say compiler should do the statement, that it should display the statement while the variable follows this expression or the logical expression. So this is also a diagrammatic way of representing the do while loop. So the statement, then the expression. If the expression is true, then it goes back to the statement until it evaluates a false false for you. This is a basic C++ program for do while loop. So we say we initialize the variable, then we say do cout the variable I, right? Then you increment that variable while it follows this condition or the expression. So the compiler should display it while it follows the criteria or expression given. Now if you want to exit from loops, we say if the condition of an iteration statement, that's a for, while, or do statement, is omitted. So if their condition is omitted, the loop will not terminate unless the user would explicitly exit it by a break, return, go to, throw, or some less obvious way, such as a call of exit. Right, so if the iteration statement for this is omitted, the loop will not terminate. That's the explicit without explicit termination. So that's an infinite loop. So if you want to terminate it, you the user explicitly exits it by a break, a return, go to, through, or some less obvious way such as call of exit, right? So now using the break, we say a break breaks off the nearest and closest switch statements or iteration statements. Right, in my previous video we talked about switch statements using the break, and in this iteration statement too we say a break is also helpful in ending or breaking of or exiting a condition or a loop. So it breaks out of the nearest and closest switch statements or iteration statements. Now we use a break when we need to leave the loop body that's in the middle. So we use it when we want to leave the body or the loop body in the middle. The break statement is used for two purposes. One, to exit early from a loop, and to skip the remainder of the switch. So this one, the first one is if it's for an iteration statement, the break helps to exit early from the loop. But if it's for a switch statement, it helps you skip the remainder of the switch structure. So this is a basic C++ program of it, using the break to exit from a condition, right? So you say for, then your initialization statements, then your loop condition, then your update statement. Then you say if that variable is equal to 5, then the compiler should display search found, then the value or the value stored in that variable will be brought here, as I said. Then you break it, so that's you've ended your, or you've exited from that loop or condition, right? So sometimes we don't want to exit the loop completely, we just want to get to the end of the loop body, right? So in that case we use a continue. So for the continue, it skips the rest of the body of an iteration statement. So that's if you don't want to exit the loop completely, you just want to get to the end of the loop body, you use the continue the continue to skip the rest of the body of an iteration statement. It could also be used in a switch statement as well. So we say when executed in a loop, it skips remaining statements and proceeds with the next iteration of the loop. So it skips that statement, the remaining statements, and proceed with the next iteration of the loop. Another basic C++ of using the continue. So this the same thing. So it continues. So we are saying for then your initialization statement, your loop condition, your update statement. Then you're given it some selection statement that if I is equal to 5, then the compiler should display the value of I, right? So when it displays it, it continues to the end, right? Note they said I is less than 10, so it continues to the it's skips it to the end of the loop body. For the nested loops, they are composition of loops that it could include the do while loop, the for loop, and the while loop. So that's the nested loop is a composition like as we did for the nested if. We said the nested loops, they are composition of loops, so you can include all the types of the loops or iteration statement as the do while loop, the for loop, and the while loop. So an example can be this. So we say the for, then you give its condition, initialization statements, and update statements. Then inside of that loop, we can bring another for loop and ask the compiler to execute a statement, right? So we can also do it this way. Let's say we initialize or we declare two integer variables, say I and j, right? And we give the first criteria for the variable I. So inside of this, we give it for the variable j, and we give a statement for the compiler to execute, right? So this is basically the theoretical part of our iteration statements. Now let's dive into the practical session, right? Welcome back. I'm using code in C++ for my programming, my practical session. You can use any other software, be it CodeBlocks, Visual Studio Code, or what have you. Right, so we begin with the iteration statement. So with the for loop, right, so we're starting with the for statement. Right, then we say for the for statements, we introduce a keyword for, then inside of the parentheses we give our criteria. So we first initialize a variable, say I, and let's say we want it to be 1, right? Then you terminate. So you've initialized the variable. Now let's give it a condition. So let's say I should be greater than or less than 15. Then you terminate as well. Then this is where the decrement operator and increment operator is needed. So we say if it follows this, right, then add 1 after, add 1 before you display the value or the variable for I. That's what the increment, the post fixed increment operator does. So this is the post fixed increment operator, and for the pre fixed increment operator is before the variable, right? So I want to do it the post fixed way, right? Then I give the compiler a statement to follow. So I say cout, let's say hello world, cout hello world. So we run this, right? So it should output, yeah, so 14. We said we initialize the variable to be 1, right? And we said I is less than 15, so that's from 1 to 14. Then after you're done, display, add 1 to every value of I before it displays. So let's make the compiler display I, right? So you see it adds 1 after it's done displaying the variable. So 1, 2, 3, 4, 5, 6, 7, 8, 9 to 14, because I said the condition is it should be less than 15. That's why it ended at 14. Right, I can also initialize I to be 0. And let's see what we'll get. Alright, so 0. Then when you're done displaying, you add 1. So that's what the postfix increment operator does. So when you're done displaying, you add a 1 to it. So that's why you have the 1, 1 plus 1, 2, 2 plus 1, 3, like that. So you get to the condition statement, then it exits for you. Right, for the for run, that's the system overflow. We just say you just terminate, right? You omit the rest of the conditions or the criteria. Then let's say it should output say hello world for us, and let's see what it will do. Hello world. So let's display this and see what we get. Right, we see it's still displaying more. So if you can see this, right? So it's there isn't any termination condition that's as it's in this, right? So this is what we mean with the explicit, without explicit termination, right? So we move on to the for loop. Sorry, the while loop, right? Let's comment this. So we multi-line comment this. So here, right? Now the while loop. So this is just while loop or while statements, right? So for the while statements, we initialize the variable outside of the parentheses. So let's initialize say y. Initialize y to be 1. You can initialize it to be 5 or 3, any value you want, but I want to do it 1. Right, then you see this is where your while is. So it's an expression, a logical expression. So you give your condition while y is less than 10, right? Compiler, do something for me. So compiler, please see out or display say, okay, first let's display y, what we'll see, right? Then when you're done displaying the value of y, increment it for me. So we say y, then the post increments, then you terminate. Now let's run this to see. Yeah. Okay, so sorry, this should all is still in the loop body, so it shouldn't be outside of the parent, the curly brace, right? So let's run this to see. Right, 1 to 3 till 9. So it basically works as a loop, just that its structure and syntax is different. It differs from the loop, right? So they are saying initialize a variable, say y. Now while the variable follows this condition, then compiler display the variable or the values of y. Then when you're done displaying that value, you increment it by 1. So that's what we see here. Let's run it. So while the variable follows that condition or the expression, we increment it by 1. So the value of y, I initialize it to be 1. And I said if it follows that condition, first display the value of y, then you increment it by 1. So this is what it does. And I said it should be less than 10. That's why it's omitted the 10 and it's exited as a 9th value. This is also basically a while loop, right? Now we move on to the do while loop. The do while loop. So this is the do while statement or loop, basically the same thing. So for the do while loop, we initialize the variable and we instruct the compiler to display a statement whilst the variable follows the condition. Then you increment the variable by, you can choose to increment before you display or display before you increment, right? So basically let's do it. So initialize a variable, say d, to be, let's use 2, right? Then we say do, right? So the do is you're instructing the compiler to display something for you. So do this while it follows this criteria. So do let's say let's display d, right? While it follow this criteria condition. Well, so let's d to be say less than and equal to say 10, right? Then when you're done, you increment, sorry, we use d, so increment, I want to do a fixed increment, so we increment it, then we terminate, right? Alright, so if we're to output this, basically we're going to get a mistake, right? Let's try it and see an error. Right, so what we're going to do is so we can, let's try terminating it over here. Alright, so 2. So we said we initialize the value, the variable d to be 2, and we said the compiler should display the value of d, but when we run it, we have just 2 up to 10, I think, or more of it, right? But we can actually say we want to increment it. So let's say we want to post increment it. So post increment, right? Then we so we say if it follows, display it if it follows that condition. Right, so we say it should display the value of d and add 1 to it, right? If it follows that conditional expression, right? And I initialized it to be 2, that's why I began from 2. Now if we wanted to make it say even numbers, we can say d plus or equal to 2, Right, so you're saying it should increment it by 2 and not 1. Right, so 2, 4, 6, 8, 10, and so on and so forth. So this is also basically the way to, or the syntax in programming a do while loop or statement. We move on to the next, nested loops, right? So for the nested loop, we say it's a combination of loops. That is a for loop, the while loop, and the do while loop. So nested loops. So let's say we have two variables, say I and j, right? I and j. We just declare them, right? For the for while loop, we say for, then your parentheses, then you give the condition of your statement. So we initialize it first, the initialization statement comes. So for say let's begin with I. So right, so let's initialize I to be 0. Then let's give it a condition. So I should be less than 10. Or let's say I should be less than 10. Then you increment or decrement I anyhow you want it. So let's use the pre increment to see what we get. So the pre increments, right? Then now we say um so we say we bring the curly brace. So this is the loop body. Remember, anything inside the curly brace is the body of it. In functions, we'll say we are defining it, right? So now let's work on the other variable j. So let's say for parentheses, then we initialize the variable j to be, say, 0 as well, right? Then we give the condition that since we've already given what's I, the value of I, we know what it is, the compiler knows what I is, and the condition it should follow, right? So we say j should be let's say less than or equal to I, right? So this is the condition. So since we know what I contains and the condition is following, we say j should be this, and we want to post increment j, right? Then finally you give your statements. So when you are done with this, you tell the compiler what it should do for you. So you give the statement cout. Say, let's just say it should process hello world. Sorry. Now let's run this to see what we get. Right, so it has given you the value for I, then it also added the value for j. So I was supposed to be, I think, 5. Okay, 10. So that's I will give you 9, right? And j will give you it should be less than or equal to I. So j also give you 9, making it 18. Right, so when you output here displaying the values 18, right? Yes, this is, let's try displaying the variable I, and let's see what. Alright, so 5, 5, 5, 6, 6, 6, 7, 7, 8, 8, 8, and so on and so forth, right? So it began, then like that. Right, so the value for I starts with the 0. Then what I said was, why we see the repetition is that I said the 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 compiler should the subtract add 1 to the value before it's you display the variable. So you add 1 to it like that before you display the variable. So that's why it has, and because it was given another loop, so this is a nested loops, right? Yeah, nested loop. That's why it has the numbers repeating itself, and we know loops actually repeats itself, right? And basically this is what. Now let's go to how to exit from a loop using the break and the continue. So we'll begin with the, or we can try outputting displaying what J will give us, right? So this is also J. So we say the value, you see for I, so J will display what I, you see I said it should increment before it displays the variable. So that's a pre-increment. So the 0, then the 0, then the 1, like that. And that's how we do it, right? So you get your desired. So this is for the J. So we do same, it loops until it reaches the value for the J, right? So this is basically the nested loop. Now trying to execute the loop using uh, the break statement or the break keyword. So we say, let's say for a for loop, say for, right? Then we initialize a variable. Let's work it I to be 0, right? Then we say that value I is less than what, say 5. Then we say we want a post increment, right? So inside here you tell the compiler what it should do. So say cout display let's say hi, right? Then you break the statements, right? So then the break, right? Then you terminate. But we can actually bring a selection statement. So let's say, okay, so if that variable we are talking about, say I is let's say it's, if it's exactly 3, right, then the compiler should do this for us. So I'm going to do right. So it breaks it after it has followed the criteria given or the condition. We said I is less than 5 and I is 0, right? But if the I is exactly 3, that's it's less than 5, then you see out high. So that means if it's not it, then it should, when you see out the high, then you break it, right? So it won't loop 3 times, but it just display the high once, then it breaks, right? But let's try making the value of I say 5 and let's see what we get. Now, because the condition was I should be less than 5, so this is basically how to use the break to exit a loop condition. Now for the continue, let's see what does the continue. So continue, still using that same method, say for, and initialize a variable y to be let's make it 1, Then we give a condition that y should be greater than or equal to, say, 9, right? Then you increment it. So inside we can give a condition, right, or a selection statement that if that value we're talking about, that variable y, right, is, say, less than 3, then then the compiler should display cout. Let's use the high again. Right, so we've given you 4. That's a loop. It should loop until it's terminated. So this one, you're going to loop till we get to a desired to what we've conditioned to our conditions, right? So we are saying if it is this the loop, right, and if the variable is less than 3, then you display high. But if the variable is greater than 3, you display nothing. But when we look here, the variable was assigned a value 1. So that's 1 is less than 3, so we have to get a high. And let's try to say continue, right? The continue keyword, then we break, we end. So let's see, so I mistakenly brought I instead of the variable y, so that's why we have the error, sorry. Right, so that's it. It gives you a null, right? But let's just say if it's greater than 3, let's see what it should do for us. Also the same thing, because it said it should continue. But let's try making this say less than 9. Right, so we get a high. 1, 2, 3, 4, 5. Right, because greater than 3, and it begins with the 1, but it should be less than 9. And when it gets to the desired, it's continuous, right? The desired, it going gets to the condition, it's continuous. So this is basically what the continue word also does. All right, what the continue word keyword also does, it's also used to as it's a loop condition. All right, thank you all for watching. Don't forget to like, to subscribe, and to turn on the notification button, so when I upload a video you'll be notified. See you in my next video. Stay tuned. Bye.